Okay, so just recently we began solving equations that required us to find the square root or cube root of a number. As those equations were in the form of x to the second equals p or x to the third equals p, where p was a positive rational number. And in lesson 5, we're going to jump into solving equations with radicals. So it's going to become a little bit more in depth, and it's going to connect to your math classes. So what we're going to do is we're going to start off with this example 1, okay, and just like in 7th grade and everywhere else, we're going to use PEMDAS, okay, so we're going to start with the parentheses first. So I'm going to distribute the 1/2, so I'm going to have x to the third plus 9 equals 1/2 times 18, so half of 18 is 9. So that's x. So 9x plus half of 54 is 27. Okay, I want to get the x to the third by itself. So I want to get rid of this plus 9x. And because it's on both sides, I will subtract 9x from the left and from the right. So then these cancel. I have x to the third equals 27. Okay, the opposite of a cube root, or a cube, is a cube root. So we're going to cube root the left and we're going to cube root the right. So x, the cube root and the cube cancel, equals some number times itself to equal 27, and the answer would be 3. And then you would always want to go back and check your work. So we would plug in 3 for x here. So 3 to the third plus 9 times 3 equals 1/2. 18 times 3 plus 54. So 3 to the third is 27. 9 times 3 is 27. 1/2. 18 times 3 is 54 plus 54. So 27 plus 27 is 54. Half of 108. So 54 does equal 54. So the answer is x equals 3. So we're going to do the same thing in example 2. Okay, we're going to distribute first, parentheses first. So I'm going to multiply this times x and this times 3. So x times x is x to the second minus 3x minus 51 equals negative 3x plus 13. Now, you can see that we have the same thing on both sides. So to get rid of those, we would add 3x. We would do the opposite of negative 3x or minus 3x. So we would add 3x to both sides. Okay. We get x squared minus 51 equals 13. Okay. We want to get rid of this plus or minus 51. We want x squared by itself. So to get rid of minus 51, we add 51 to both sides. So those all canceled. So we have x squared equals 64. The opposite of squaring something is a square root. So we square root the left and we square root the right. The square root of x squared is x. The square root of 64 is 8. And then you would want to go back and check this. When we square root something, our answer could be positive and negative, because negative 8 times negative 8 is positive 64, so our answer could be both positive and negative. So we would have to check both options. So 8 minus 3 minus 51 equals negative 3 times 8 plus 13. I'm using the positive option first. So 8 times 5 minus 51 equals negative 24 plus 13. So 40 minus 51 equals negative 24 plus 13. Negative 11 equals negative 11. So yes, that does work out. And then we have to put in the negative option. So negative 8 times negative 8 minus 3 minus 51 equals negative 3 times negative 8 plus 13. So negative 8 times negative 11 minus 51 equals 24 plus 13. So negative 88 minus 51 or this will be positive. Negative times a negative is positive. Equals 37. 37 does equal 37. So the answer would be that 8, or x equals 8, and x equals negative 8. Both answers are correct. So, in our exercises, find the positive value of x that makes each equation true, then verify that your answer is correct. Okay, so we're going to solve for x. Check it. So when you verify, that just means check your answer to make sure it's correct. Okay, so here we go. 5x minus 5x, those two cancel. So we're left with x squared minus 14 equals 67. We add 14 to both sides. X squared equals 81. We would square root both sides because this is a square. So we would get x equals 9. And I'm only going for the positive value because it asks for the positive value. So I'm only going with 9, positive 9. So then I would check that. So 9 squared minus 14 equals 5 times 9 plus 67 minus 5 times 9. So 81 minus 14 equals 45 plus 67 minus 45. We subtract here on the left. We get 67. These two cancel, equals 67. And I'm going to also do both of them. I know I said positive, but I'm going to do both. So negative 9 squared minus 14 equals 5 times negative 9 plus 67 minus 5 times negative 9. So negative 81 minus 14 equals negative 45 plus 67 plus 45. So again, those cancel. Over here we get, oh, this will be positive, negative 9, the whole thing is squared. So we would still get 67 equals 67. So both solutions check. The answer is positive and negative 9. So then we explain this. How we did this. So to solve first, okay, you wanted to always get the x, or the variable that is squared by itself. So I used the property of, let me do all this here, equality. Properties of equality to put the equation in the form x squared equals 81, which was right here. Okay. Then I square root both sides to solve for x. Okay. We're gonna solve and simplify. So we're gonna, because they're parentheses, we're gonna distribute. So x times x is x squared. X times -1 is -1x equals 121 minus x. -1x and minus 1x and minus x are the same thing. So I would add 1x to both sides. These cancel. I have x squared equals 121. Because this is squared, I'm going to square root it. So then we get x equals positive and negative 11. Because negative 11 times negative 11 is positive 21, or 121, and 11 times 11 is positive 121. And we're going to check it, because you're going to have to make sure that you did these right. So 11 times 11 minus 1 equals 121 minus 11. So 11 times 10 equals 110. 110 does equal 110, so that's a positive. So negative 11 times negative 11 minus 1 equals 121 minus negative 11. So negative 11 times negative 12 equals 121 plus 11. So we multiply this 132 equals 132. So both are correct. So this is the correct answer. Number 3, a square has a side length of 3x inches and an area of 324 inches squared. What is the value of x? So for area, we know that it is side times side. So 3x times 3x equals our total, which is 324. So area of a square equals side squared. So 324 equals 3x squared. So 324 equals, we're going to take, this is going to be 3 squared, which is 9, and x squared. So we'd first want to get x squared by itself. So these two are being multiplied. So the opposite of multiplication is division. So we divide both sides by 9. These cancel. We get x squared equals 36. Because this is squared, we're going to square root both sides. So we get x equals 6. Okay, and I didn't put -6 because the length cannot be negative. Okay, when we're just solving for x, it would be positive and negative, but here we're solving for the length. Okay, so this would be 6. Okay, so then we're going to check it. 324 equals 3 times 6 squared, so 324 equals 18 squared. 324 does equal 324. So this would be our value for x. Okay, number 4. Oh, we're going to get into some cubes here. So here we go. Here we want to get the cube by itself, so we want to get rid of the plus 14. So the opposite of plus 14 would be subtract 14 on both sides. So we get negative 3x to the third equals negative 81. We divide both sides by negative 3. X to the third equals negative divided by a negative is a positive. 81 divided by 3 is 27. So then, because this is cubed, we're going to cube root both sides. Cube root it. So then we have x equals 3. And then we would always check it, of course. Okay, so negative 3 times 3 to the third plus 24 equals negative 67. And this only has one value because whenever you cube root something, it's only positive. Okay, so negative 3 times 9 right. Oh, this is to the third. This is 27. Plus 24 equals negative 67. 3 times 27 is negative 81. Plus 24 equals negative 67. We subtract and keep the larger sign. This is negative 67 does equal negative 67. So the answer is x equals 3. On 5, we're going to distribute. Okay, so we have x to the third or second plus 4x minus 3 equals, and we're going to distribute again, 4x plus 19.5 times 4. So x to the second plus 4x minus 3 equals 4x plus 78. Okay, I want to get x squared by itself, so I've got to subtract 4x on the left and the right, and I have to add 3 to the left and the right. So these cancel, so I have x to the third equals 81, or x to the second, sorry. So we would square root the left and square root the right, so x equals positive and negative 9. And then we would check it. So 9 times 9 plus 4 minus 3 equals 4 times 9 plus 19.5. 9 times 13 minus 3 equals 4 times 28.5. 9 times 13 is 117 minus 3. 4 times 28.5 is 114. So 114 does equal 114, so that checks. Our other one, we would have to use negative 9, so negative 9 times negative 9 plus 4 minus 3 equals 4 times negative 9 plus 19.5. So negative 9 times negative 5 minus 3 equals 4 times 10.5. Negative 45 minus 3 equals negative 42. Or this will be positive, sorry. So this will be 42. I don't know why I'm putting negatives. So positive 45 minus 3 is 42. Does equal 42. So the answer is positive and negative 9. On number 6, okay, Here we go. We're going to distribute again into the parenthesis. Okay, so 216 plus x equals x times x squared is x to the third minus 5x plus 6x. So 216 plus x equals x to the third. I'm going to combine like terms on the right side, so negative 5x plus 6x is x. Okay, I'm going to get rid of the common terms on both sides, so I'm going to subtract x from both sides. So 216 equals x to the third. This is a cube, so I'm going to cube root it. So I get x equals 6. And then we're going to check our answer. So 216 plus 6 equals 6 times 6 squared minus 5 plus 6 times 6. So we add this together, we get 222 equals 6 times 36 minus 5 plus 36. So 222 equals 6 times 31 plus 36. So 222 equals, we would multiply that and get 186 plus 36. So 222 does equal 222. That checks, so your answer is 6. And we have one more, and this is where we bring it in with the Pythagorean theorem. So we're going to add in roots with the Pythagorean theorem. So, in the diagram here, we have the length of the hypotenuse. Okay, this is the hypotenuse, which is C. We have the length of a leg, which we can let be A, and then we are looking for the leg B. So on here, in A, we're trying to determine the value of x, so that the square root multiplied by 4 satisfies the equation. So we're trying to determine x so that the length of the leg satisfies the Pythagorean theorem. Okay, and I'm going to go ahead and set this up. We know that the Pythagorean theorem is a squared plus b squared equals c squared. And I've already labeled them, so I'm going to go ahead and plug in. So 5 squared plus 4 square root of x squared, the whole thing is squared, equals 11 squared. Okay, so we have 25 plus, 4 squared is 16. The square root of x squared, the square and the square root cancel each other out, so we're left with 16x equals 121. 11 squared is 121. Now I want to get x, the term with x by itself, so I'm going to subtract 25 from the left and from the right, so I have 16x equals 96. Then I would divide both sides by 16. X equals 6. And then we would go back and check it to make sure that that was correct. Okay, so go back to this equation that we wrote up here. This is the equation that we will check it in. Alright, so 5 squared plus 4 times the square root of 6 equals 11 squared. Oh, and these are all squared. The whole thing. Ooh, 25 plus, And you would multiply this out. So this is squared, so 16 times the square and the square root cancel each other out, times 6 equals 121. So 25 plus 96, does that equal 121? Yes, it does. Oh. So it does check out. So here, you're going to square the 4 and get 16, and you're going to square the square root of 6, and the square root and the square cancel each other out, so we're just left with the 6. Okay?